Okay, so consider a triangle with height x and length y. If we have the smaller triangle with length d and height small d, we can use the ratio of small d and d to find tan theta, which then we can use to find what x over y is, because these triangles are similar. So we know that d over y, no, d small d over d is equal to x over y. So that means that we can find, which is the aim of this experiment, of y. We want to find y, which is the length of my table here. And we can do that using the formula of y equals dx over small d. So I'll explain each different term in that. So small d is 7 centimeters. It is the distance. So it is the distance between this pencil and this pencil, the horizontal distance, and large d is the vertical distance, which changes. Yeah. So, and the way that I found x is that I lined myself up like this, and I looked at where the pencils intersected, and then tried to find it using this makeshift meter ruler. Well, it's not a meter ruler, it's like 50 centimeter ruler. So yeah, I did that, and I found different values for for d and x, and this is my data which I found. In this data here, I think that there's quite an obvious outlier of 28 and 20, because all of the other data seems to be as d increases, so does x. But this is an anomaly right here. So let me show you my my calculations. So the way that I found y was, if you plot a graph with d on the y-axis and 1 over x on the x-axis, the gradient will be dy, where d is just 7 centimeters. So I converted all of my units into SI units and put it into Excel, and I found the 1 over of the reciprocal. And then I plotted a graph right here, and which is the same graph you see here. So we know from Excel tells us that dy is equal to 0.0523. So then we can take this value and divide it by d, and then we get the final value to be 0.747 meters. So the next thing I did is I found the actual value of by just using my ruler and just measuring the table normally, and I found that the table or the distance between it's not really the distance of the table, it's the distance between this part of the ruler here and where the other ruler meets the table. So it's a little bit less than the actual length of the table, and I found that to be 0.995 meters, and I found then I found my percentage error to be 25%. So I wouldn't say that this experiment is accurate. I think my apparatus were very limiting. And there was an outlier in my experiment, so my data doesn't really agree with itself. So I don't think this experiment was precise or accurate due to the limitations of my apparatus. If I were to do this again, I'd probably do it at school, and I would probably have a better ruler. I think a meter ruler would probably be a lot better, because it was extremely hard to kind of work out distances when everything's to the centimeter. So yeah, it's my experiment.